Welcome to Talking Event Driven, the podcast about the world of event-driven architecture. You will hear seasoned professionals sharing invaluable insights about their challenges and experiences in event-driven architecture.
Hello and welcome to Event Driven. With me today, I have Dunith. He's a developer advocate at Redpanda. And we'll be talking about the interplay and the role of AI with Event Driven. First off, I'm going to just let you introduce yourself, Dunith. Who are you?
Yeah. Hi, Bryan. Thanks for having me, first off. So I'm a senior developer advocate at Redpanda Data. So basically, my job is to increase the awareness of Redpanda among developers. So basically, we as a streaming data platform, we provide this large-scale event streaming ingestion capability for event-driven application developers. So my job is to create content around these use cases and evangelize the use of streaming data and event-driven architectures, reference architectures, demos, and code samples among developer communities and increase the engagement. So that's my typical responsibilities at Redpanda Data. Before Redpanda, I came from integration background, middleware. So I had these data integration work, and then I eventually ventured into developer relations from there, and then get the chance to work on real-time analytics projects. And here we are at working with Redpanda. So excited to be here.
Yeah, all right. So coming from an integration background, so what were like your first interactions with event-driven architecture and by extension, brokers or let's say message brokers, event brokers in the next evolution?
Absolutely. So if I go back maybe 10 years ago, so I was working for a middleware company called WSO2 from Sri Lanka. So WSO2 had WSO2 ESB, which is kind of an enterprise service bus. So this enterprise service bus enabled integration between heterogeneous systems. So we work with many event brokers like ActiveMQ, IBM and there are many event brokers. So actually, we did several enterprise integration pattern implementation in terms of event-driven architectures like guaranteed delivery, and then event brokering, event filtering, dead letter channels, and those kind of patterns during this integration. So that was some good memory I have, still have.
Yeah, mainly from ESBs then. So how was the transition then to let's say the Redpanda context, where you're more closely to a different implementation of a Kafka, where let's say the transformation logic doesn't have to be in the broker, since we're doing smart endpoints and dumb pipes in a certain sense. How was that transition then?
Yeah, that was a good question. So basically, at ESB, we had the meat of the transformation at the middleware itself. So ESB itself had the knowledge of all the transformations. But compared to that, then when we consider something like a streaming data platform, something like Redpanda or Kafka, so we have, like you said, it's dumb pipes and smart endpoints. So all the transformation logic goes towards producers and consumers. So that was a big transformation. But it's not a pure black and white world now. So we now have this in-broker transformations with Redpanda as well. That means it's not either white or gray, black. So there's a bit of a gray material here. So if you need high throughput, high performance transformation within the broker, Redpanda allows you to do that with WASM runtime. So that allows you to write your simple transformation logic using JavaScript or Rust and deploy it to the broker, and broker will take care of the execution. So that's just another modern development I'm witnessing these days compared to the classic event-driven architecture I saw 10 years ago. So
All right. I take it that it's pretty important who owns that transformation, because the concept of your event driven forces the logic to be in the ownership of your producers
Correct.
and your consumers, but you can perfectly put a transformation that's owned by a producer or consumer just closer to your broker. But how do you typically manage that specific part then? Like, how do you keep that transformation in the ownership of one of those endpoints?
Yes. So basically, I mean, there's no defined pattern, but there's this concept of decentralization. That means uh, if you if you write a transformation, then you must own it from end to end. That means you should come up with the design, then you should implement it, test it, deploy it, and then maintain it. So uh, if I come with when it comes to this event-driven microservices, I think uh, sorry, I think you asked about in-broker transformations. What's your question about in-broker? Oh,
The ownership. So you make a transformation. So say that you say, okay, I will transform the language that this speaks to a sort of a standard that we want to operate
yes.
on inside the broker. The transformation from the source aligned data, in a certain sense, the thing that the application speaks to, the common language in a producer context, that transformation is in the ownership of your producer in a certain sense. So since they put it on the broker, how do you manage that so it stays in the ownership of that producer? So they are responsible for operating that. Do you have the handholds for it and so on?
Yes, I mean, there can be some governing bodies so basically, events. So I think the first step is to have some sort of a concrete event contract or event schema in place. So this is some kind of a governing body. So i- I've seen these kind of things in event-driven solutions. So basically, uh, when we design a particular system, event-driven system, what we do is event discovery. So it's like a workshop. So we try to
Mhm.
understand different domain events, something like business events, and then we try to catalog them, and then we try to uh, uh, implement them in the event broker side. So basically, it could be something like a event catalog or schema registry, some kind of a. So that's the implementation detail. Um, and then uh, and then both event producers and consumers has to conform to this event catalog, event schema. And if producers happen to evolve a schema or something like adding a field or changing a field, uh, they must update and communicate that to the event catalog so that the downstream consumer applications won't break. So there won't be any surprising downstream breakages when there's anything happen. And that being said, uh, producers are not being hold of creating new changes, because we need to promote the innovation across the platform. So they are allowed to evolve their schemas to meet new business requirements, but the component, the event catalog or some kind of a governance body in the central piece will make sure it's regulated and it's communicated to all the producers and consumers in seamless manner without
Mhm.
getting surprise issues.
Yeah. All right. So the in-broker transformations just plug into this entire system in a certain sense.
Yes.
All right. And yeah, to sort of take it one step further, then we were going to talk about how the EDA flow interplays with AI. Have you seen any specific cases, for example, where these transformations or other kind of things that you do with event-driven data, how it can, yeah, be empowered in a certain sense by what we can do with AI nowadays? There's many options, I think.
Yeah, I mean, it was here, it was there already. So I'd like to frame my answer into three different sections. So first, the classic AI and ML. So this is, the classic machine learning models and then
Mhm.
inferencing. So basically, uh, in these situations, we could use event-driven architecture as the backbone for inferencing and real-time model training. Say, for example, uh, if a user is browsing a website, e-commerce websites, we can trigger events like, okay, the page, this page has been viewed, and then a user added this item into a basket and so on. And let's say by analyzing these events, we could we can actually consume these events by using a different consumer, and then this consumer can do a model inference, and maybe we can derive a personalized item for the next item. So that happens as a result of an event. So that's an event trigger, and then this consumer can respond to this event quickly by maybe sending a personalized offer or maybe a discount, so that it will act as an incentive for this particular buyer to complete the purchase. So that's a good use case. I mean, it is there already. If you look at modern websites, modern e-commerce application, Netflix, and entertainment. The second phase is the large language model. So that means generative AI. So here the model is pre-trained, but the thing is, its knowledge has been cut off at some point. Most of the models, so its knowledge is limited. But when we apply certain things like RAG pipeline, retrieval augmented generations, we need some kind of a large context window and constantly updating memory knowledge. So the way we achieve that is using databases, something like vector store. So we use this additional knowledge, we transform them into embeddings and store them in vector databases. So how would that architecture fit into event-driven architecture? So one way is we can use event broker as the event backbone. Say, for example, let's say we have a knowledge base in a company, and let's say they have this company holiday policy, vacation policy in a document, and then this knowledge base is used by a chatbot. So employees can ask question about how much vacations I'm allowed this year. So those kind of things. And this AI application at the receiving end will analyze this thing, and it will use the retrieval augment generation to inference this vacation guide and then answer. If HR department wants to make a change, we can capture it as an event in real time and update it to the vector database. So then we can make sure that the next time the employee asks the question, he gets the most accurate information. So that's the second part of the use case in EDA use case in AI. The final part is something new, agentic AI. So that means we have autonomous agents communicating and working without human in the loop. So basically, they will use event-driven architecture as a backbone for communication and controlling. So and scheduling and orchestrating their workflows. Sorry, that was a long answer, but yeah.
It's a lot, yeah. But I mean, I think the first one where you are purely working on categorization and other in-band transformations and in-band reactions in a certain sense.
Correct.
There's always also the challenge of like how do you feed this back into your model? So say that I have the recommendation engine that you say for my series that I'm watching on a Netflix site, or the things that I'm buying.
Yeah,
that also evolves. So you need to sort of feed that back. Like if I bought baby stuff on Amazon, then they probably want to suggest more baby stuff to me. So that means that the recommendation engine needs to first suggest it, and in a certain sense also know that it needs to suggest it more in the next site. So in a purely event-driven setup, have you ever had to actually create this kind of flow? How do you increment your recommendation engine in that sense?
Yeah, I've seen those kind of things, and I'm not a machine learning expert, but I'll try my best to answer that. I think the way that is done is using a real-time there's this real-time training of machine learning models. So basically, it can collect user feedback, something like we can offer some feedback questions to user, for example, through UI tips. So say, for example, when users browsing uh, the site, maybe we can present some 5 product recommendations, and also with that, we can simply ask some kind of a simple question. Would you like
Mhm.
to get more recommendation like this? Then we can give the user with a simple question, yes or no. And then if the user presses no, then we can capture it as an event, and then we can feed it to the ML pipeline that trains that machine learning model. Uh, Either we can do it in real time, or we can add it to
Yeah,
the
increments.
inference. Yeah.
Yeah. All right. Cool. But the second case you're talking about is more like the updating part. So, in your experience, then, have you seen a lot of cases where let's say, the business events that we publish, they are perfectly contextualized to what's actually happening in your process? Have you seen that it provides let's say, an amplification, or makes it very easy to work with these clean data sets, so that events are for your machine learning, or do you see different challenges in there?
That's a good question. I think the most events we get from the business systems are not in a perfect shape for to be fed to machine learning systems, because ML systems and models, they expect clean semantic data. So we need some kind of pre-processing must be happen before we pass them into the machine learning models. So in the meantime, we can do something like some pre-processing, something like maybe we can clean them, deduplicate, and then uh, uh, probably join events together through lookup joins, and then we can enrich the event payload to have more dimensions for the more features to these downstream machine learning models. I think those kind of transformation can be done through a middleman maybe another stream processor or something, or it could be done through a simple in-broker transformation. So those are 2 options. Yeah.
Yeah. Do you have any, let's say, recommendations or something how you would go about it? Because you could have an event, order has been closed, order has been shipped, and then you have another thing that customer has signed up for a newsletter or something else. All these things give a sort of a context. So you need to make make a sort of an overview of something that you can offer to the machine learning model. Do you have any practical examples of that, or things that you say really watch out for those kind of things?
Yeah, I think machine learning models, they need more features to uh, to to make more accurate inferencing. I think if we collect small number of features from the original business event, then maybe we can uh, do some processing in the middle. Something like maybe we can do some, let's say, for example, the we collect the latitude and longitude from the original business event. But for the machine learning models, it requires the postcode and the physical address of the user, customer, sorry. And then, so there's a feature mismatch. So in the middle, we can write a simple stream processing job, or some kind of some microservice or something to enrich this model. Say, for example, we can get the lat long pair and reverse geocode it, and find the postcode and the physical address, and pass it as a enriched or transformed event to the downstream ML model. So
Yeah. So
yeah, I
yeah.
mean, yeah. Just to give you a physical example, real world example, this could be like geo-targeted promotions. So we capture users' email latitude and longitudes, and then in the middle, we can precisely generate their exact location based on certain third-party data. So we call it data blending. And then based on that data, the targeting or marketing models can do geo-targeted promotions and those kind of targeted campaigns.
Yeah. All right. Cool. And then your final ones are the agents. So do you have a practical example of such an agent that interplays with events and the event broker?
I mean, I haven't tested them by myself, but I've been reading upon different examples, especially on this, you know, self flying drones. So basically, I mean, I've seen a couple of examples of those videos where uh, when you say, for example, if they are programmed to do uh, package delivery or goods delivery, and then uh, when they are in flight, they can intercept, they can perceive their surrounding conditions as events. For example, a change of wind speed or change of humidity, the rain, and those kind of things. And then agents can react to this based on these event conditions in real time and in real time. For example, um, I'm just trying to come up with an example here. Say, for example, if the wind speed is high, and if and then it comes as an event, and then and the percentage of batteries also comes as an event. So by correlating these two events, the agent may decide what's my optimal path to this thing. So that could be one thing. The
Yeah.
other could be, yeah, sorry.
Do you then imply that, for example, for the drone scenario or some other scenarios, that you need an event broker on the drone itself to be able to do that, or do you see that as a communication relay? Because the real-time capacity on, for example, the drone would be quite important if you want to use it for actual steering.
Yes, that's right. So I think both ways are possible. I'll come to the challenging part later. So I think in most cases, uh, I think there should be some kind of a centralized broker deployed somewhere, and maybe must be accessible to the drone. I'm not sure too much. I'm not. I'm not too much sure about the internals of that. So maybe there are some ways we can communicate with the drone. Let's say, forget about the drone. Let's say self-driving car or something. So it, anyway, it needs some kind of a connection with uh, centralized broker to get the, and this broker will act as the event backbone, and then there will be a control plane where it controls these, federates these vehicles or drones. So they will give them control signals as events, and then based on these events, they can uh, react. The other way is edge, uh, edge-based processing or edge-based analytics, where drones or self-driving cars or these edge agents itself, they can have their own broker. So I've seen, I mean, if you consider something like a device platform, something like Raspberry Pi, with today's modern hardware capabilities, we can deploy a simple, small broker inside that. So we try to do something with the Redpanda some time back. We try to deploy a Redpanda broker within a Raspberry Pi. So if Raspberry Pi becomes an agent, then it will have its own uh, broker there. So that could be a possible development in the future, because these devices are getting, the hardware is getting more creative and innovative and more accessible for more developers. So that's why.
Yeah, in-car systems are getting pretty powerful nowadays. So.
Yes.
Yeah,
Correct.
but then you're inferring that, okay, you can have a local installation which has its own kind of interplay. It does kind of lots of things. It calculates things. It responds. So, for example, I would not want to rely on an uplink to know if I need to brake my car.
Yes.
But you do need to talk to, for example, a centralized one who does the calculation for your routing, keeping into account traffic situations, other cars that you're routing, and so on. So to keep the bigger picture.
That's right.
Yeah.
I think we can have low latency mission critical communication within the device, within the broker itself, and then we can optionally reach out to the central broker for uh, more accurate decisions and more not so latency sensitive actions,
Mhm.
like control
Yeah.
signals and those. Yeah.
And the agents themselves basically act upon the triggers that they get. So breaking could be a very simple one based on just some image processing, but you could just do the same in, for example, financial trading or whatsoever, that you get the feed of what's happening, what kind of information that's flowing, and you just have it respond autonomously. That it infers a new event and asks other things to respond to it. That's kind of the agent flow that you're talking about. Then,
That is exactly correct. And I would like
yeah.
to add to that. So that's just about a single agent. But how about having multiple agents communicating and doing the same task together? So that will be it's like a hive-minded use case. It's like say, for example, you have a big task and you have a swarm of robots, agents, like a collection of robots. So, and this task must be done in conjunction with each other. So in that case, we can fit this thing into event broker, because there can be like task queues, and then there's this pub sub style communication. So each broker can have their own queue for communication, and these brokers uh, sorry I think each agent can have its own dedicated queue for communication. So for example, if one agent wants to send a message to another agent, he can put it in a queue. So that's point-to-point communication. So that would be a really cool use case if you want to do something like sequential task. So
Yeah,
I mean,
give it a
yeah,
I'm also thinking more in the direction of, in a certain sense, what you're saying is that every agent, if they interplay with each other, in a certain sense, is an application, or what we used to call an application. So you can just sort of align, like the event-driven architecture or the events that you define a common language, how you're going to talk to each other. And I'm just going to create a number of agents around my business, which have a very well aligned, like, this is what you own, this is what you will decide, do what you need to do as an agent for it. And
correct.
that you just replace what used to be a custom application implementation with an agent in that sense.
That's correct. I like your positioning. I think this agentic AI, it's like a trendy word. I think it's like a hype around these days. I mean, uh, we can boil everything down to the traditional event producers and consumers we've seen in the early days. I think every agent could be an application. So either it could be a producer of events, or it could be a producer of consumer of events the based on the task it is assigned. So so there, and then the communication pattern would be point to point or publisher subscribe, depending on the nature of the problem they are assigned to
Yeah.
solve. So I think
All right.
yeah.
It's an interesting idea. Opens a lot of possibilities. I don't know, have you seen one of these in practice?
No, not yet. I think there are many discussions going around. I think the most hottest topics would be agentic AI these days. So people are trying to uh, jump from generative AI to agentic AI these days. I'm still trying to get my hands on how to implement such kind of agent, multi-agent environment. You know, there'll be more interesting use cases like federating these kind of agents, and we'll have a leader there, and then so yeah,
It's
soon you
it's
will
like,
see more practical use cases there. But
yeah,
for me, I couldn't find any yet.
it's like building a business with AI agents. You need a manager, and then you.
Uh, yeah, maybe we can. The one aspect I would see is customer supporting bots. Like maybe probably we can have a pool of agents. Like they'll represent customer support agents, and then they can have their own boss or some kind of a leader that dispatches uh, the tasks among these bots, and then so these agents can sense the dynamic environments they are working on. For example, if the customer sentiment changes from nice to rude, and then the agents will adjust themselves. Like maybe they can tone down their uh, communication style, or maybe they can do some kind of a action, corrective actions. So I think those kind of use cases will be common in the future. So,
All right, cool. It's an interesting thing. Yeah, moves us nicely to what I wanted to ask next. Like, where do you see it all going in the future in that sense? I mean, event brokers have a role to play in that, in a certain sense, and event-driven architecture is also in there. But the agents, is that the end game for you, or do you think it's still going to head other places after we are there?
I think event-driven architecture, it's an architectural pattern. It's established. I think the principles are there. They are not going to change forever. I think so. Basically, the decoupling of systems and the event catalogs, event schemas, producers and consumers, point-to-point versus pub-sub communication, that will remain forever as a foundational piece. And on top of this foundation, there can be many technology trends, like we said, we discovered today. Classic machine learning was another foundation block that leverages EDA, and now we are using generative AI to get the most out of it. And then agentic AI could be the next big thing. But um, if I'm reading this crystal ball right, I think there can be many more. I don't know what to expect, but one thing is sure, it's EDA will not shift, or it will not change. So most of the technology trends will benefit from it because of the scalability and the decoupling, loosely coupled nature of this architecture, because that will power more diverse technology teams to work together. Say, for example, if one team is greenfield and they are working on the latest technology trend, and we have another team, they are quite established and they are working with the already existing technology. So both teams can work together by communication messages through a broker. So I think that would be the way to go. So EDA would be the foundational layer there.
Yeah, it's a concept that plays well with any kind of developments in that sense. So we'll never go out of fashion. We'll just have to keep up with the volumes of everything.
Correct. That's right. Yeah.
All right.
I think.
Okay.
Yeah. Sorry.
Yeah, go ahead.
I think we'll have to think a little more about the event storage. I mean, the storage story of the brokers. I think what I see today is events. When you talk about event-driven architecture, events are most meant to be, temporary, and they're like volatile. And then once the producer or consumer reacts to events, most of the time the event is gone. But if we with streaming data, I think we can do this event retention for long-term periods.
Yeah.
And then the good side is, now with this iceberg and then table format integrations, the events in these brokers can now be synced, uh, uh, moved into object stores, cost-efficient object stores, where we can store them in AWS S3, Google Cloud Platform S3 those buckets, and etc. I think with open table formats like Iceberg, Delta, and Huddy, we can have a common standard for event at rest. That means uh, m- uh, future use cases, like, for example, if I want to train my agent with these events, I can bring my training infrastructure into these Iceberg tables and read from there. So that means the burden of storing events for long term is is offloaded from brokers to this data lake house infrastructure. I think that would be some future thing.
Yeah.
Yeah.
That's the thing that's already in a certain sense possible. I mean, with the shadow indexing and everything else,
Correct.
it's literally you decouple the compute from the storage, and then
Exactly.
you get the storage to deliver its value while it's at rest as well.
Correct.
So that's exactly what's interesting there, and that's also, I think, the key thing about event-driven architecture in a certain sense. Okay, the communications are volatile, but
Yeah.
what actually happens in your business processes is an important piece of information that you'll never get back if you make it volatile.
Yes.
So there is a lot more information in there than what a specific representation in a point in time is. The story that something tells is a lot more important than what the end result is in many
Correct.
cases.
That's correct. The real value lies not in a single event, but if you piece several events together, you can tell a story. I think that's the
Mhm.
narrative to take the EDA to the next level. I mean,
Yeah.
EDA is good delivering, reacting to current events, but if you collect more events together, then we can have a good story. And then, especially if you are targeting data and AI for the future, the more events you have, the more business value you can derive. So that could be.
Yeah. And I'm also very curious if we have, for example, businesses that have basically how they operate on every single domain in their application in their landscape as events. If we release certain AI process optimization things on top of it, what they will be able to find. Because in a certain sense, they should be able to tell us, like, okay, that's inefficient, that you can do differently in a certain sense, without us having to come up with the ideas first. Because that's how we currently operate in many businesses.
Can you give me some kind of a example for that question? Something like
So a typical process optimization. So say that you have an
oh,
order
right,
flow
right.
and
Yeah,
you do various steps and you say, okay, we shunt it into that point and then we take it out of
right.
there and then so on and on. Right now, it's kind of relies on somebody responsible for example, warehousing or something else in that entire process to really think about, I think we can do this more efficient. The bar is basically pushed. He needs to increase efficiency. He gets to do it with less resources, and he starts questioning how I can do this better. An AI agent with this amount of context could do that proactively without being, let's say, pushed until he becomes or until it becomes a problem. So I'm wondering if you think of all this context that you're giving, what they will be able to get out of that with pure AI. Like, this is an inefficient process and do it like this and everything that goes on around that.
Yeah, that's a really good question and some kind of a tough question to answer. I haven't had experience on such kind of self. I think I've seen several self-improving agents, like the one example I saw. Uh, there were some agents that can self-correct themselves. Say, for example, now we have co-pilots, right? I mean, GitHub, they offer co-pilots, and then based on say, for example, for a given agent, based on its interaction, it can keep track of what went well and what went wrong, and then uh, these can be scored as feedback for this agent. So it could be something like a self-reflection for this agent, and based on this self-reflection and the score, maybe the agent can correct itself. So, for example, it can update its own code base. Um, I haven't seen such incident other than in science fictions, but but
We
in
all
future,
remember Skynet.
yes. but there's a possibility because uh, these co-pilots are really good at fixing bugs and detecting bugs as well. They can, and then the continuous deployment and integration is already a solved problem in this world. DevOps is there, DevSecOps is there. So I think it's just a matter of writing and fixing its code, and then it will be automatically deployed, tested, and rolled out to the agent itself. Uh, uh, I think that's one way of me thinking. That's how this self correcting or self feedback agents would work in the future.
Yeah, and EDA is the perfect facilitation for it. All right. Okay, I think we are at the end of our time now. So I'm going to thank you for your participation here, and I hope you had fun.
Of course. Thank you, Bryan. Thanks for having me. Hope the discussion will be helpful for the audience.
I hope so too. There's only one way to know, and that's the feedback that we'll be getting.
Right.
So yeah, thanks, and yeah, hear you later.
Right. Thank you. Bye.
Thanks for tuning in to another episode of Talking Event Driven. We hope you enjoyed the insights and stories shared by our incredible guests as much as we did. If you found value in today's discussion, don't forget to subscribe, rate, and leave us a review. Stay tuned for more enlightening conversations. Until next time, keep innovating and stay event-driven.